As you can see, study guide problem number 34, we're given the information that this person is throwing a ball straight up into the air with a velocity of 40 feet per second, and straight up in the air means the angle is 90 degrees and from a height of 7 feet. We're trying to figure out is what are the parametric equations, and so the parametric equations would be x equals, we have the velocity times the cosine of the angle multiplied by t, and the cosine of 90 degrees is 0, so this is 0, x equals 0. And then y equals the velocity, well, let me do this first, negative 1/2, and since it's in feet per second, that's 32, that's g, t squared, plus v sub 0, which is 40, multiplied by the sine of 90 degrees, so that's going to be 1, and then multiplied by t, plus then the height, which is 7. So let's clean that up a little bit. So we get negative 16t squared plus 40t plus 7. So those are the two parametric equations, and that's your answer for part A. Maybe there's not even any letters, but anyway, there's part A, the parametric equations. So the question is, how long is the ball in the air? Okay, so I'm going to probably have to pause this and do a little calculating, but how long is the ball in the air would be set y, so 1, 2, 3, 4. So part B, how long is the ball in the air? Set y equal to 0 and solve that equation. And when you solve that equation, you get, well, I'm going to pause this, and so I'm going to run it on my calculator. So I just paused the video, set y equal to 0. You solve the equation using the quadratic formula, and the negative 40 minus the square root yields the 2.664 seconds. So when t is equal to 2.664, the ball finally hits the ground. And so that's what the first question says, how long is the ball in the air? That's the 2.664. When is the ball at the maximum height? So it's not necessarily going to be half of that, but I'll pause the video, run the calculations, and I'll get back to you. And before I do the calculations, I'll go ahead and set it up for you. But to figure out when it's at its maximum height, if we look at this particular function, that's a quadratic function. Maximum height occurs at the vertex. So the y-coordinate of the vertex of this function is going to be, so it's a y-coordinate of vertex. And that guy right there is the max value. So I want to make sure you guys understand that. The maximum value of a function is going to occur at the y-coordinate of the vertex. Well, how do we find the y-coordinate of the vertex? We find the x-coordinate of the vertex by doing what? So think about that. The x-coordinate, okay, of the vertex, and this is where you live. It's negative b over 2a. Okay, so negative b over 2a is equal to negative 40 divided by 2 times a, which is negative 16. So b is 40 and a is negative 16, and that's 40 over 32. 40 over 32, which we can simplify to even more. 8 goes into the top by 5 times, and 8 goes into the bottom 4 times. So 1.25. If you were to plug that in, okay, so if you plug that in, let's do that in green, y of the 5/4, and that's going to yield the y-coordinate of the vertex, and I will go ahead and pause and then get back to you. There you go. So y of 5/4 is 32, and that would be 32 feet. So this ball reaches a maximum height of 32 feet. Okay, and then part D, maybe I'll do that on the other side. What does it say? What? Oh, sorry. I've already answered the question. This 5/4, guys, represents the time. So the x-coordinate of the vertex, or you could say the t-coordinate of the vertex, because it's y is a function of t here, that would be the time when max height. That's a nice sentence, isn't it? Time when max height. Okay, hopefully you understand what that means. See me if you don't. So that's the time. That answers that part of the question. And then the maximum height is actually the 32 feet. There's your max height. Max height. So we're done. That's it.